Technology in the contemporary world is overwhelming, and sometimes we forget the role of nature and its laws working behind modern labors.
Gravity and atmospheric pressure.
What we are about to show you today is all about the drainage system, particularly plumbing and the waste pipes.
In the study of plumbing, it is important to know the different parts of the piping installations and their functions. The effectiveness of plumbing installation depends upon the strict observance of the natural laws of nature such as gravity and atmospheric pressure that affect the whole system.
Most of the failures encountered in plumbing installations were due to the non-observance of these natural laws and the grave abuse of its function. The drainage installation of a plumbing system comprises of three major components: the drainage, the waste, and the vent, or simply called as DWV. Let's differentiate and talk about all of it while you watch these videos.
The drainage pipe refers to an installation that receives and conveys discharges from water closet with or without waste coming from other fixtures, and in simpler terms, a pipe responsible for removal of water in a particular area. On the other hand, the waste pipe is any pipe in a drainage installation that receives the discharges of any fixture except water closet and conveys the same to the soil branch, soil pipe, or house drain. It is smaller in size than the soil pipe due to the kind of waste it receives from various plumbing fixtures suspended in water waste including grease, lint, matches, hair, garbage, and many other objectionable substances. The vent pipe, however, functions in a plumbing system as air passage or conduit to ventilate the drainage and the waste pipe installation.
Ever wondered where the solid human waste is being discharged? It is through water closet to either soil branch, soil pipe, soil stack, or house drain.
Soil branch refers to a horizontal pipe affixed by the word soil. The word soil connotes a pipe receiving discharges from water closet. On the other hand, if this soil branch does not receive discharges from water closet but from other fixtures only, it will be classified as waste pipe. Whereas soil stack is a vertical pipe installation where the soil branches terminate. The pipe is called stack being installed vertically, and the word soil is affixed because it receives human waste from soil branch. Otherwise, it will again be classified as waste stack.
There are general conditions for a good waste pipe installation, and this mainly includes the following.
1. By making the right choice of materials, as dictated by the character of the waste to be drained and the service to which it is intended for. Any waste pipeline that conveys a large amount of acid must specify acid-resistant material, example of which are fixtures serving chemical laboratories, plating, engraving establishment, and others that use acid of various kinds. However, waste that are coming from domestic and commercial kitchens that sometimes contain acid of different kinds have small negligible quantity and therefore does not require the use of an acid-resistant pipe. 2. The conservative use of fittings. It refers to the right choice of the right kind of fittings for a particular change of directions, turns, or offsets. Unwise use of fittings and shortcuts that does not allow smooth passage of waste should not be allowed in plumbing installations. There were many self-proclaimed plumbing experts who installed pipes in what they called shortcut method, where correct use of joints and fittings were not properly observed. Some factors that caused these improper installations were working time and working pay. But the question is, how sure are we that the installations are clog-free? Pipe installations that fail or break too soon may have been due to use of too many wrong type of fittings. To avoid these failures, some recommendations listed include the use of longer radius of fittings on a vertical to horizontal directions or horizontal to horizontal changes, use of long sweep fittings on horizontal changes, use of Y and 45-degree fittings on vertical to horizontal direction of changes, and the use of T-fitting design for vertical run with lateral branches only, since using it on horizontal installation will create a tilted or crook joint connection called premature waistline defects. 3. Right location of the cleanouts. The location of cleanout must be indicated in the plan. It should be sized equal to the diameter of the waste pipe, where it is to be connected to avoid interference in the rodding or cleaning process. Also, it must be readily accessible to the plumber in case of waistline stoppage. Cleanout is a receptacle of the plumbing system accessible on floor, walls, or ceiling. It is equipped with a plug or flush plate so designed as not to impair the aesthetic view of the room. The waste pipe installation must be provided with an ample number of cleanouts strategically located to be opened in case of pipeline trouble. 4. Right slope or grade of the pipelines. The ideal position of horizontal waste pipe were those installed at 2% slope, meaning the pipe was installed with an inclined ratio of 2 cm per meter length. For instance, a 3-meter pipe installed as a waistline will have an inclination of 6 cm. The latest scientific tests and experiments conducted by the National Bureau of Standards, sponsored by the Housing and Home Finance Agency, showed that wet venting and stack venting are safe in certain type of installations. The experiments revealed that the trap seal loss or the loss or escape of standing water inside the P-trap occurs when the grade or slope of the pipe is increased from 2% to 4% or may be caused by siphonage induced by rapid flow of waste inside the pipe. It is also referred to as water seal escape. 5. Using the right size of pipe. According to the National Plumbing Code, the size of the waste pipe intended to receive waste from the fixture must be of sufficient diameter, adequate enough to accommodate the velocity of flow, making it as nearly scouring as necessary, flushing or washing out dirt or grease by flowing through to prevent the silting of the pipe. Service efficiency, nevertheless, was believed to increase with the larger pipe, which unfortunately triggered the disagreement among people in the plumbing industry as it holds no scientific evidence. However, the said disagreement was resolved as the Uniform Plumbing Code Committee formulates data as guide and references in determining the size of the waste and other drain pipes. The findings were enumerated as follows. 1. Waste pipe must be of sufficient diameter to afford adequate velocity of flow in order to make them as nearly self-scouring. However, increasing the size of the drainage pipe does not guarantee effective scouring action or self-cleaning ability of the pipe. Self-cleaning ability is present when the liquid and waste inside the pipe flow smoothly and simultaneously together. 2. Water flow inside a larger pipe is relatively shallow. The solid waste does not flow on shallow water but tend to remain at the bottom of the pipe. This is practically the most common cause of the many clogging problems of the drainage installation. 3. Drainage pipe must be of the right size to have a liquid flow of about 50% of the pipe diameter, meaning that the flowing water inside the pipe must have a depth equal to 1/2 of the pipe diameter. 4. For instance, if the pipe is 100 mm diameter, the water flow inside the pipe must have a depth of about 50 mm to attain the scouring action. This is where the 2% slope becomes effective. 5. On the other hand, too small pipeline is subject to overloading of flow. The tendency is to create back pressure, siphonage, and floor flooding. 6. Correct manner of joining the pipes. Injudicious connection of fittings should not be permitted in any plumbing installation. Each kind of pipe has its own manner of joining recommended and specified by the manufacturers. For instance, cast iron pipes are joined using solvent plastic cement or by a special fitting connector. Remember that any alteration or deviation from the manufacturer's specifications will only endanger the effectiveness of the pipe joints. Lastly, 7. Providing stable and rigid support. It plays a crucial role in proper functioning of piping systems, carrying pipe weight and its contents and maintaining the integrity of the system.
Moving on, the National Plumbing Code strongly endorsed the use of fixture unit value as waste load in determining the size of the waste pipe. How? The Uniform Plumbing Code Committee conducted numerous tests on various plumbing fixtures in order to determine the amount of water in each fixture discharges in 1 minute interval through their outlet orifices.
Test results showed that the floor drain, lavatory or wash basin, or every 15 square foot of roof drain has a fixture unit equals to 1. Residential sink with 1.5. Bathtub, kitchen sink, laundry tub, shower bath, sink in hotel or public has a fixture unit of 2. Slab sink and combination fixture has 3. Urinal with 5. Water closet with 6. And an 8 fixture unit for 1 bathroom consisting of water closet, lavatory bathtub, and overhead shower or water closet, lavatory, and shower compartment. Based on their findings, the wash basin being one of the smallest fixture discharged waste at approximately 1 cubic foot of water per minute interval. The committee finally decided to establish the unit fixture and called the water discharge as one fixture unit, representing 1 cubic foot or 30 liters of waste discharged by the fixture in 1 minute interval.
The National Plumbing Code also gives a measurement in determining the diameter of a pipe.
In here, we can see the diameter of the pipe in metric and English system. The maximum number of fixture units that may be connected in one horizontal branch, not over 3 branches or a stack with 3 more branches intervals, and in 1 branch interval or total in stack.
For us to understand how it works, let's do some illustration.
Let us determine the size of a horizontal waste pipe to serve 5 urinals, 3 lavatories, 8 showers, and 2 slop sinks. First, we must find the fixture unit load of each one of the fixture by referring to fixture unit value, where a urinal has 5 unit, lavatory has 1, showers with 2, and slop sink with 3 unit load. Then multiply it to their corresponding numbers to total their value, and we can get 50 units. Then let's look to the other table. Under the column of one horizontal branch, 50 units could be well served by a 100mm or 4-inch pipe.
It seems that the 100mm 4-inch pipe with a capacity to serve 160 fixture unit load is too large to serve 50 fixture units as computed. However, since the 50 fixture unit falls under the parameter of 100mm pipe as formulated by the National Plumbing Code, it has to be followed without a question. Specify the use of 100mm pipe diameter.
Plumbing design, particularly the sizing of the pipe, should be determined by way of mathematical computation using the fixture unit values. However, regardless of the results, when it is smaller than what is promulgated by the Plumbing Code as presented in the tables, the code must prevail. One probable solution for a person who is thinking of the economy is to install a graduated size of pipe from say 30 to 100mm diameter in order not to violate the provisions of the code. The idea is very good and acceptable on the premise of economy. However, it should be analyzed carefully considering the cost of cutting different sizes of pipe, providing reducers and various fittings, plus the time delay and the high cost of labor.
Otherwise, we might as well forget the idea towards unrealistic economy.
Let's have another illustration. Let's determine the size of a horizontal branch waste pipe for one lavatory, one residential sink, and one slab sink. Like the first one, let's find the total fixture units. So for lavatory is 1 unit, residential sink with 1.5, and slab sink with 3 units. All the fixture are only 1 pieces, so the total is 5.5 units. Under column 1, horizontal branch, the 5.5 fixture unit is nearest to the value of 6. Under column 1, a 50mm pipe will be satisfactory to drain all the 3 fixtures. So, 50mm diameter size will be used for the horizontal branch waste pipe. To compute the size of each fixture drain is not necessary because the manufacturer has already provided each fixture with the right size of drain. Most plumbing installation frequently suffers from grave abuse of functions by human elements and behavior. Some people think and regard the installation as a means of disposing almost any kind of unwanted waste. On the other hand, people who observe proper disposition of their refuse seldom experience waste pipe problem.
Knowing about fixture units, it would make it easier for us to learn about waste pipe and other fixtures.
Waste pipe is classified into 2 types, the direct waste and indirect waste. Direct waste is one with terminal directly connected to the plumbing systems, and these are urinals where pedestal, stall, and trough are its kind. The bathtub under it are silts, foot, and bidet. Lavatories like wall hang, pedestal, and 2 pieces. Sinks like slab, pantry, and kitchen sink. Showers where there is a single stall or a gang. The drinking fountain, laundry, laboratory, and hospital fixture. The indirect waste, however, refers to a connection with terminal not directly connected to the plumbing system. Fixtures served by indirect waste are soda fountain, bar waste, refrigeration, and also drinking fountain.
For a particular fixture, either served by direct or indirect waste, recommend the following sizes.
1. Sink waste. The minimum size of waste pipe for sink is 38mm or 12 inches. But because of the material suspended in it, the practice is to use 50mm or 2-inch pipe. The National Plumbing Code provides that the waste pipe must be short, direct, free from offsets, and provided with ample cleanouts accessible for repair. 2. Stop sink. Stop sink is tapped either on the floor or walls. Traps on the floor shall be 75 or 100mm and 50mm for traps installed on the wall with a cleanout plug. 3. Scullery sink, 50mm. 4. Pantry sink, 38mm. 5. Factory wash-up sink, 50mm. 6. Bathtub, 38mm minimum to 50mm. 7. Lavatories, 50mm. 8. Shower bath, 50mm. 9. Urinal, 50mm. 10. Laundry tub, 38 to 50mm. 11. Drinking fountain, 32mm. 12. Lavatory waste, 50mm. And 13. Hospital fixtures, 50mm.
It is interesting to note that some fixtures could be served well by using waste pipe of smaller diameter based on the volume of water it discharges in 1 minute interval.
The code, however, regulated the use and size of pipe drain to maintain good sanitation through an efficient drainage system. One example is the urinal, wherein large amount of foreign materials are dumped and subsequently lodged into the short run of the pipe. Examples of foreign materials that are found in clogged pipes are gum, cigarette butts and filters, matches, and many others. Likewise, the chemical action of uric acid of urine produces gelatinous substances that settle down and become objectionable sediments, which are difficult and extremely hard to remove.
This is only one of the many reasons why the Standard Plumbing Code Committee issued limitations on the diameter of the waste pipe to serve plumbing fixtures. Generally, the 50 mm pipe is required for all the types of urinals. Knowing all of this would help us to avoid our pipes being clogged and would help us live hassle-free. Don't you agree? Now that's many minutes. See you next time.